चैंपियन कोर्स किन के लिए है? जो IIT JEE एडवांस का एग्जाम दे रहे हैं, मेंस का एग्जाम दे रहे हैं, उनके लिए है। ये कैसे ज्वाइन कर सकते हैं? आपको यूट्यूब चैनल पे जाना है, वहाँ पे ज्वाइन बटन है, मेंबरशिप लेना है यूट्यूब का। आप मेंबरशिप लोगे तो मैं इस कोर्स को ज्वाइन कर सकते हो। इसमें आपको पूरा कोर्स करवाया जाएगा, आपका लाइव डिस्कशन होगा, DP दी जाएगी, यानी पूरे ऑर्गेनिक केमिस्ट्री की कोर्स की गारंटी अच्छे से करवानी आपको सिखाने की मेरी होगी। तो आप ज्वाइन कर सकते हैं यूट्यूब के मेंबरशिप प्रोग्राम के थ्रू। ज्वाइन बटन पे क्लिक। हाय, हेलो टू एवरीवन। Now today we are going to study the open chain conformer of butane and other molecules. Now let's start with butane. The model of butane is in my hand. The black represent carbon and white represent hydrogen. Now you can see that it is an eclipse conformer because this carbon is parallel to this and this hydrogen parallel to this. This is an eclipse conformer. Or we can say that it is fully eclipse conformer. If I start rotating this bond, then I will get staggered conformer. Now, what we are going to study, we will rotate this carbon-carbon bond and we will draw different conformer formed by this carbon-carbon bond rotation. And then we will compare the relative stability that different conformer formed by rotation of carbon-carbon bond. So, our aim is to rotate carbon-carbon bond and draw different conformer and compare the relative stability. Now, let's start with the conformer of butane. If you check syllabus of IIT JEE Advanced, it was specially mentioned in our advanced exam that rotation across carbon-carbon, especially butane, is mentioned in JEE Advanced syllabus. Now, what we have to do, draw conformer of normal butane C2C3. Now, what is the meaning of C2C3? Means across second and third carbon. Now, how to decide the numbering of this carbon? It will be decided on the basis of IUPAC nomenclature. So, first of all, we will number according to IUPAC. C2C3 means we have to draw conformer across this carbon-carbon bond. Now, this carbon has 3 valency. Apart from this carbon has 3 more valency, 2 hydrogen and 1 methyl. Similarly, this carbon bond, apart from this sigma bond, other 3 valencies are 2 hydrogen and methyl. So, what I am going to do, first of all, I am drawing this conformer across C2C3 and this is 4th carbon. Now, this is in this conformer, these methyl are parallel, means carbon-carbon are 0 degree. It is known as fully eclipsed. Now, why it is known as fully eclipsed? Because this methyl is completely hid by another methyl. This is fully eclipsed. Similarly, this hydrogen eclipse, hydrogen eclipse. Now, I can show you fully eclipsed by this model. This represents fully eclipsed. This H is parallel to this carbon is parallel to this, and this hydrogen is parallel to this. You can zoom the screen and watch this fully eclipsed form. Got it? Now, what we are going to do, we will rotate this carbon-carbon bond and then we will draw different conformer. Now, if we rotate this carbon-carbon bond by 60 degree, how much rotation is going to be there? I rotate it by 60 degree. Now, after 60 degree rotation, this 60 degree conformer is known as Gauge conformer. So, if I am rotating, front carbon is fixed, this carbon is fixed, and I am rotating back carbon 60 degree, and the carbon-carbon 60 degree is known as Gauge conformer. This is the nomenclature of this conformer. Similarly, if I rotate this carbon by 300 degree, so this methyl will be here and we will get again same conformer. Means if there is a 60 degree or there is a 300 degree rotation, we will get Gauge conformer. Methyl in this position or this position, both conformer are known as Gauge conformer. Now, again I will rotate this by 60 degree. Again there is a 60 degree rotation. Then it is known as partially eclipsed. Because of different groups, it is known as partially eclipsed. If I again this rotate by 60 degree, the front carbon is fixed and back carbon is rotating. So we can say it is now carbon-carbon at 180 degree and we can say it is a staggered conformer. So what I did, I rotate this carbon-carbon by 60, it is known as Gauge. Against 60 rotation, it is known as partially eclipsed. Against 60-degree rotation, it is known as staggered conformer. So first of all, pause the video and write these conformer in your class notes. Then we will further explain, then I will explain you what is their relative stability. Pause the video and write in your notes fully eclipsed, gauge, partially eclipsed, staggered. Now let us compare their relative stability. Which one is the most stable? This is the most stable conformer because these bulky group are 180 degree. Yeah, we can say that this type of orientations is most stable conformer. Got it? And this is the most unstable conformer. This is fully eclipsed, is highly unstable. Whenever there is a eclipse type formation, it is unstable. This is highly unstable. This is also unstable, but this is the most unstable because of two bulky group, methyl. In this case, there is a H-methyl, there is a less bulky group. Then what is the relative stability? The most stable is our staggered. Then there will be a gauge, because staggered is sometimes similar orientation of, gauge is a similar orientation of staggered. Now after gauge, there will be partially eclipsed. And then again it is a fully eclipsed. Got it? So note down, the relative stability is staggered, more stable than gauge, then it is more stable than partially eclipsed, and most unstable is fully eclipsed. Now, if we draw an energy diagram, this is energy and this is the carbon-carbon bond rotation, or we can say dihedral angle. This is the dihedral angle. Now, what is the meaning of dihedral angle? The dihedral angle means angle between two specified group in Newman. Angle between two specified group in Newman projection is known as dihedral angle. So initially, for example, if I specify carbon-carbon, this is butane. If I specify carbon-carbon, then what is the dihedral angle? In this case, if I specify carbon-carbon, dihedral angle is 0 degree, dihedral angle is 60 degree, dihedral angle is 120 degree, and dihedral angle is 180 degree. One more thing is there, if I rotate by 120 or rotate by 240, in both cases I got partially eclipsed. Okay. So first of all, write down definition of dihedral angle, the angle between two specified group in Newman projection. Now at 0 degree, this is a fully eclipsed, yani this is our unstable. At 60 degree, it is gauge, and again at 120 degree, it is a partially eclipsed. This will be at highest level, then will partially eclipse. Then at 180 degree, it will be a staggered. And again at 240, there will be a partially eclipsed. And again, gauge will return at 300. As I explained you, the gauge will be at 60 degree and gauge will be at 300 degree. And after 360, again we will got fully eclipsed. Fe means fully eclipsed, P means partially eclipsed. So we will got gauge conformer at 60 and 300 degree. We will got partially eclipsed at 120 and 240, and at 180 degree it will be a staggered conformer. So first of all, write down this, draw this energy diagram. Got it? Now find dihedral angle. If I ask you, explain dihedral angle of FCCI, it is 180 degree. How it is 180 degree? This is fluorine, the back side is carbon, front side is carbon, and this is iodine. तो FCCI, तो what is the dihedral angle? 180 degree. If I ask what is the dihedral angle of FCCCL, then FCC and this is CL, it is 60 degree. So what is the definition of dihedral angle? Angle between two specified group in Newman. Similarly, what is the dihedral angle in this case? This is F. We have to find dihedral angle of F, carbon, carbon and chlorine. Got it? So this is fluorine, backside carbon, front side carbon and chlorine. This dihedral angle is 60 degree. And if I consider this chlorine, then FCC chlorine means it is a 180 degree. This means there may be a two dihedral angle. It depends upon the type of atoms. Got it? Now if I ask you question, find dihedral angle. If I ask you question, find dihedral angle, this means the question is incomplete. First of all, I have to write find dihedral angle of lowest energy conformer, highest energy conformer, or I have to specify it. If I write find dihedral angle, then we can find dihedral angle in Newman projection. We have to convert this into Newman, then we can find dihedral angle. Now if I ask dihedral angle of carbon, 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 what we have to do? First of all, we have to convert this into Newman, because the definition of dihedral angle is angle between two specified group in Newman. So if we draw Newman projection of this is H. We already learned how to draw, how to convert Chouhan to Fisher to Newman. We can convert Fisher to Newman. This is the Newman projection. This is carbon, front and back side are carbon. This means the dihedral angle will be at 0 degree. Got it? These two carbon, carbon are parallel, means it is a 0 degree. So definition of dihedral angle is angle between two specified group in Newman projection. So write this example of dihedral angle, first example, second example, third example. Now you have to find rotational barrier of ethane and the HH eclipsing energy is 1 kilocalorie per mole. Find rotational barrier of ethane and the data given is if hydrogen eclipsing is 1 kilocalorie per mole. What is your answer? Now first of all, you should know what is the rotational barrier. The rotational barrier is energy difference in between most stable conformer and least stable conformer. Now what you have to do? You have to draw two conformer. The most stable conformer and least stable conformer is known as rotational barrier. If I ask question in this given energy diagram, what is the rotational barrier? So this is the most stable conformer and this is the most unstable conformer. So this energy difference, most stable and least stable conformer is known as rotational barrier. So first of all, write down definition of rotational barrier, energy difference between most stable conformer and least stable conformer. Now try this question. What is the rotational barrier of ethane? Now as we know that rotational barrier is energy difference between most stable conformer and least stable conformer. So this is our most stable conformer staggered. Assume the energy of staggered as 0. You have to assume energy of staggered as 0. Then next we have to draw most unstable conformer of ethane. Now this is our most unstable conformer. in this hydrogen is eclipsing, this means energy increases by 1 kilocalorie per mole. Then what is the rotational barrier of ethane? If this energy increases by 1 kilocalorie per mole, similarly this is also increases by 1 kilocalorie per mole, and this is also increases by 1 kilocalorie per mole. So what will be the energy difference between these two? Answer will be 3 kilocalorie per mole. This is the rotational barrier of ethane. The most important thing is to understand in this type of question is that we have to assume energy of most stable conformer as 0. Then we can find out the difference between the most stable and least stable. So write the answer in your notebook. Now similarly, if I ask you what is the rotation barrier of normal butane, is it greater than 3, equal to 3 kilocalorie per mole, or less than 3? What is your answer? Now in case of normal butane, we have to draw most unstable conformer. So which is the most unstable conformer of normal butane? It is our fully eclipsed. Let us assume the carbon-carbon eclipsing energy is 4 kilocalorie. Now why it is 4 and why it is less, why it is 1? Because more the bulky group, more will be the eclipsing energy. More bulky, more repulsion, more will be the eclipsing energy. So this means in this case, the rotational barrier is 6 kilocalorie per mole. Yani means it is a greater than the value of ethane. As the size of carbon increases, with the increase in carbon size, rotational barrier will increase. So we can say that rotational barrier order is normal butane has more rotational barrier than propane, and propane has more rotational barrier than ethane. This is the order for rotational barrier. So write down in your notes, the rotational barrier order is normal butane, propane, ethane. Now this is very interesting example. In some cases, the gauge is more stable than staggered. Usually staggered is more stable, but in some cases gauge is more stable. So this example you have to remember. This is our point to remember. This is famous glycol. The glycol means ethane 1,2-diol. We will draw conformer across this carbon-carbon bond. Now in this case, the gauge is more stable than staggered. Now why gauge is more stable? Because of this intramolecular hydrogen bonding. Because of this intramolecular hydrogen bonding, gauge is the most stable conformer. If OH are away from each other means if OH on staggered conformer, there is no intramolecular hydrogen bonding. This means more the intramolecular hydrogen bonding, more will be the thermodynamic stability. Which conformer is more stable? This is more stable. So whenever these two groups, if there is any two group which are doing hydrogen bonding, in that case gauge will be more stable than staggered conformer. So what is the condition for gauge is more stable than staggered? These two groups must undergo intramolecular hydrogen bond. Write example in your notes. Now try this. Draw most stable conformer of the following. Write down all the example. First try all the example, then I will explain what is the exact answer. In this case, you have to write only draw most stable conformer of succinic acid at low pH at high pH. Now let's discuss the answer. In case of propane, the carbon-carbon bond is not mentioned in the given question. Why carbon-carbon bond is not mentioned? Because of identical carbon-carbon bond. If I number the carbon from right hand side or left hand side, both lead to the same carbon-carbon bond. Same type of orientation is there. Therefore, no need to mention exact carbon-carbon bond. Now in case of propane, which is the most stable conformer? If you go, second carbon has 2 hydrogen and 1 methyl. First carbon has 3 hydrogen. This is the most stable conformer. In normal hexane, so first of all you have to draw normal hexane. Then you have to number the carbon. We have to draw across C2, C3. Remaining valency will be hydrogens. This means C2 have 2 hydrogen and 1 methyl. C3 has 2 hydrogen and 1 propyl. So we have to draw most stable. This means we will draw staggered. Now for this C2, this is our C2, H, H and methyl. Backside carbon is C3. So C3 consists of 2 hydrogen and 1 propyl. 1 propyl and 2 hydrogen. Now this is the most stable conformer of normal hexane. You may draw this conformer or this Newman in other way also. For example, if methyl here and propyl here, the same orientation. This means you have to keep this methyl and propyl at 180 degree. Now you have to draw 2-methyl pentane. This is butane, this is 2-methyl pentane across C2, C3. So this is our second carbon, this is our third carbon. Now valency of this carbon are hydrogen and 2-methyl. So first of all, hydrogen, methyl and methyl. Now this carbon has 2 hydrogen and 1 ethyl. 1 ethyl. We have two options. Either I can keep ethyl here or ethyl here. Since there are 2 methyl, if I kept ethyl in this position, it lead to the steric hindrance with 2 methyl group. So where it will be a minimum steric hindrance if ethyl is in between methyl and H. So if I draw ethyl here, this means it is unstable conformer. Now in example D, since the OH and F, there is an intramolecular hydrogen bonding in between these two. Therefore, which one is most stable? 𝐸𝐥 is most stable conformer. Now next, 3-hydroxypropanol. What you have to do? First of all, draw 3-hydroxypropanol. This is 4-hydroxypropanol. 1, 2, 3. And these two groups can form hydrogen bond. Yes, they can form hydrogen bond. This means which one is most stable conformer? Again, the intramolecular hydrogen bond, 𝐸𝐥 is the most stable conformer. Now you have to draw most stable conformer of this in Newman projection. Then what should be our approach? Our approach is we will construct a circle here and we will put this atom in this circle. So what should be our approach? I can draw one more. What we have to do? Draw the circle, delete all the bond in the circle, delete the connecting bond, and then we have to put this carbon on this. Now when we put this carbon on this, we have to draw stable form. Therefore, I will draw most stable form like this. There is a hydrogen below that carbon. Beside this carbon, there is one of the valency is hydrogen. Now we have three valency, H, H and methyl, and we have to draw most stable conformer. These are carbon-carbon. This means to minimize steric hindrance, we can keep H or methyl, which will keep minimum steric hindrance. For minimum steric hindrance, there should be a hydrogen here. If there is a methyl, the repulsion between two carbon. Then methyl is this is hydrogen. Now this is the most stable conformer of this cyclic. Now try similar to, a similar example is G. F and G are similar. Now try again the example G. Then what you have to do? Draw the circle and the backside carbon is our 6-member ring. This is our 6-member ring, and we have to draw most stable conformer. So I will draw staggered form, and since all valencies are similar, so we have only one option, and that option is keep all this methyl on same position. This is the most stable conformer of F. One more trick is there. If you want to convert this into Newman, one more way you can draw this. For example, if there is an absence of ring, and then I can ask you to draw most stable conformer of this organic molecule, then what should be your approach? What you will do? You will construct a circle. These three are 3-methyl. You will draw 3-methyl, and the backside valency is our H, ethyl and ethyl. Carbon, carbon, carbon. This is carbon, carbon, carbon. Got it? If I ask to draw you the most stable conformer of this open chain alkane, then you will draw like this. This carbon has 3-methyl and the backside has 2-ethyl and hydrogen. Now originally molecule has this ring. Now you can reconstruct this, cut and then paste. 1, 2, 3, 4, 5, 6. I draw in some absurd manner because of different carbon-carbon bond. If you draw properly, you will get proper shape like this. Now in this question, draw the most stable conformer of succinic acid. You have to draw most stable conformer of succinic acid at low pH and high pH. To solve this question, you must know what is the structure of succinic acid. Now as we know that this is the structure of succinic acid, butane 1,4-dicarboxylic acid. Now what is the meaning of low pH? Low pH means solution is acidic. High pH means solution is basic. So what happened to this succinic acid if at low pH? At low pH, the structure remain as it is. If there is a high pH, suppose there is a pH 12, then there will be a base, then there will be acid-base reaction, then CO2H will convert into CO2 minus. Now what you have to draw? Now this is the structure at low pH and this is the structure at high pH. Got it? Now at low pH, this is the most stable conformer. Which is the most stable conformer? GOTH. Why it is most stable? Because of intramolecular hydrogen bonding. At high pH, there is a negative charge. So since both valencies consist of negative charge, the negative negative must be away from each other. Therefore, in this case, staggered is more stable. To minimize negative negative repulsions, they must be at anti position. The purpose of this example is to explain you, as the pH changes, the structure of that organic molecule will change. It may change. So just pause the video and write in your class notes. You can also, I can explain this change of structure by using that example of acetic acid. As we know that acetic acid is an acid and it has a pK value of 5. If pH is greater than pK, means if I ask you what is the structure of acetic acid at pH equal to 7. At pH equal to 7, it will convert into this. How? If pH is greater than pK, it will convert into basic form. So if there is a pH 7, it will convert into this. At pH 12, it will convert into this. As pH increases above 5, the acid will convert into acetate ion. So this will be the structure at pH greater than 5, and this will be the structure at pH less than 5. By using the pK of particular acid, we can determine how it will exist in different pH. Sometime in the reaction we write that this reaction gives best yield at pH 10, pH 9. Now how that pH is decided? That will be decided on the basis of the pK value of that particular acid. For example, in some reaction we require this acetate ion. Our purpose is to use that acetate ion, means we require basic solution. Then what should be the pH of that reaction? The pH of that reaction must be greater than pK, so that the acid convert into acetate ion. For example, in some reaction we require this acidic form, not acetate ion. In that case, what is the pH? pH should be less than pK, means pH should be less than 5. If pH is less than 5, it will exist in acidic form, and this is its acidic form. Got it? Now that's all for today. In next lecture, we will continue our series of conformers. You have to prepare proper notes, and if you have any doubt, you can ask me in comment section. Have a good day and enjoy and learn properly and prepare properly for JEE Advanced. Thank you. Jai Hind.